All righty. So I was saying we've got Kerberos authentication. We've got RPC and REST protocols that also use Spinego. RPC supports SASL. We've got good. Oh, is is that better? We've got a bit of a cold. I apologize. Um, so we've got RPC supports SASL for all the authentication, privacy, and integrity methods that Hadoop implements, or not Hadoop, Java. The REST protocol supports end-to-end TLS for privacy. We've got proxy user support for privileged services, and we've got encryption and REST. Looks like a pretty good list. However, we do have some things we have to work on. The next slide, I'm not possibly going to be able to cover all of these things, but we'll hit on as many as possible. RPC privacy performance is terrible. You take about a 30% throughput hit. Spinego isn't using mutual authentication with Kerberos. It's kind of fire and forget of the service ticket. Our TLS performance is poor due to Java. TLS mutual authentication needs to be easier to use. KMS client reliability, if any of you have been watching JIRAs, it needs a lot of work. KMS server scalability, we're going to touch on that quite a bit. Authenticated URL, auth URL, token variants, all of the things that people try to use for security, they're very brittle. We don't have the same parity between proxy users between the REST and RPC protocols. We need to commonize that. RPC call queue throughput under varying loads, workloads, it's great in some cases, not so great in others. RPC replay, I can't cover all those. So let's move along. RPC, I've heard from a lot of people that their name node just doesn't scale well, but we've had, I think, about 385, 390,000 operations per second sustained over an entire weekend without a production incident. Years ago, that was unheard of. Fair call queue is largely what allows us to scale to that because it's excellent for read workloads. Problem is we need to do work on heavy write loads because the abusive user looks like their call volume is lower than everyone else. Therefore, they stay in the top priority queue while the people doing read ops start floating down. I think there are some people in the community that are looking into ways to do that or solve that. As I mentioned before, the QoS for privacy has significant performance penalties. And even if you do use it, Kerberos will use strong ciphers like AES, but the token-based authentication uses RC4, which anybody in the security world is not going to be using anymore. Now, before I got distracted with KMS work, I came up with a proof of concept, swapping in Netty for the IPC layer so that we can drop the SSL engine that Netty has because it is supposedly highly performant and it'll allow us to finally implement that certificate method that has been sitting dormant in the IPC and UGI layer for a long time. Now here's why that last point is not done. Encryption zones. We're trying to deploy them in production. The crypto stream support is pretty good. There's not that much of a performance hit. However, the KMS, the most crucial piece, its throughput initially was scaling to only a few thousand operations per second. Now compare that with what I was just mentioning before, that the name node in RPC is capable of hundreds of thousands of operations per second. KMS just cannot keep up. And there's a whole variety of reasons that I've been trying to address. I'm sure there's more. Connections aren't reused, so the KMS is just getting bombarded with SSL connections for every request. Java's ECDH algorithms, the implementation is terrible. Just don't even try to use them unless you only want about 1,000 ops per second. Session cache, I've commented on a public JIRA. This needs to be changed because it's unlimited in size, 24-hour timeout. Your clients aren't coming back for that long. You'll run out of memory. Just recently found this out. Java is using dev random instead of urandom. Dev random blocks. You go to Oracle's website, and for their WebSphere web server, they even tell you to switch to using urandom or the performance will be poor. And let me tell you, initial testing, has provided a phenomenal boost. There's this synchronized blinding randoms that I talked about. It, it gets it out of that code block. There's also this RSA Montgomery math that's used during the RSA cores negotiation. The very sad part is there have been 4 intrinsics. This is, for those not aware, native assembly implementations of specific methods present in Java since the early days of Java 7. They were disabled because a unit test failed on Solaris. So turn them on. I will be posting a public Jira with those flags. These last 2 things, dev random, Montgomery, I have gone from, I think, about 4,000 operations per second, which is about what the first ones did. These 2 get closer to 10, and I've got some internal limiting factors with Yahoo code that, I mean, could potentially push this much higher. If you think about it, the name node, when you make a request, the locking, the path resolution, the permission checking, the logging, all of these things that go on compared to the KMS, which has a super simple, small REST protocol. Here's a few bytes. Can you please decrypt this for me? We should be able to easily run circles around the name node. And I'll need all your guys' help with this to achieve it. Now, on the name node side with encryption zones, memory consumption is an issue. We're always very sensitive because whenever you're running very large name systems, it quickly adds up. The file encryption info, we need to work on that because it's a protobuf encoded in an XAdder, and it's got the key name and the key version. The key version is key name @number. So you've got the key name duplicated twice for every single FE info. We need to dedupe that, and I'm hoping that we can do that through the string table patch that we're trying to get integrated into the next Hadoop releases. Because otherwise, you're telling people, can you please keep your key name really short? But then you start doing things that the key name looks obfuscated. You want it to be readable as much as possible. So if we do this, we'll cut the memory usage way down. We need to get a key re-encryptor that doesn't do recursive descent of the entire tree and doesn't impose limits like no renames. I mean, that just means that you can't use your name system while the re-encryption's happening. I believe, unless it's changed, that's the implementation on trunk. We have nothing in 2, and we would really like to get something in 2.8 to handle this. Now, what I'm hoping we can do is come up with the means of crawling the inode map, which will be much, much cheaper than trying to recurse and keep track of where you are. Rashad was doing quite a bit of work on this before he went to Salesforce, but we were trying to get to the point that we had better support for non-super users to copy their encrypted data, because otherwise, right now, you have to decrypt all the data and re-encrypt it, which is not efficient. And the main things to try and achieve that is allowing non-super users to have access to the encrypted bytes and to have the ability to set this FE info XAdder. And I don't believe we've got an internal patch available yet that we put in that we avoid blocking the RPC handlers ever, even during an edict cache miss. I believe the current implementation in the community, get the right lock, do a bunch of stuff, including path resolution, let go of the lock, try to get the edict, get the lock again, re-resolve the path. We've got something that throws in the rare case that the edict is not available. So there's a number of things we can do on the name node. Now, I've actually burned through my slides faster than I thought. It seems like on trunk that we've got a number of heavyweight niche features that have been going in. And I would like people to try and use external plugins or abstract away the features as much as possible. If I had $1 or $2 for every time I heard, don't worry, it won't affect you if you don't turn it on, I'd be a lot closer to retirement. Um, so we also have to, everyone knows, reduce the overhead of block reports with, as we have higher and higher density of storage and the reports get larger, even the per storage ones, you can block for tens, hundreds of milliseconds. Now, we set our block report interval, I think, on the order of like 24 hours. We generally trust the name node to do its bookkeeping correctly. But even then, you can get some significant pauses. A while back, I serialized the block reports and the IBRs into a single thread because there wasn't much sense in having all the IPC handlers all blocking on the name system. So I think we can leverage that change that I made to start releasing the lock periodically during a full block report. Since all the operations are serialized, we know that we won't have concurrent block report processing going on, which could confuse the system. We already let go of it periodically while processing IBRs. I think we just need to let go in the middle. Decommissioning overhead. For any of you with large clusters, if you decommission a couple racks, it can have a pretty big impact on performance. I believe in 2.7, there were a number of changes made that made it better, but it still needs improvement. And I encourage any brave individual to do some profiling and figure out what we can do to reduce the overhead. It appears to be the initial scan of all the blocks on the node. Block placement. Anybody who's ever looked at that code, it's a very confusing little twisty maze. And since I believe 2.7 and now 2.8, it's become significantly more expensive than it was in the past. There were changes made to the topology to try and detect how many live nodes were on the rack, etc., which has amplified how expensive it is. And if you use, I think the storage policy or space-aware placement policy that has to pick 2 nodes randomly and then pick the best, that just further amplifies the performance loss. Recursive operations, let's please make these client-side. The recursive delete, anybody who's had a large tree be deleted and just sat there and cried as their name node froze for minutes, 5 minutes at a time, knows the danger of having recursive operations on the name node. Things like the key re-encryptor on trunk are doing a recursive operation. They try to let go of the lock, but it's still something better left to the client side or a scan of the inode map. Recursive operations, bad. And anybody who's known me for the last few years, GC has always been a performance concern for us. It used to be the main limiting factor to our scalability. Today, it hasn't been as much of an issue, but only because we use a 16 gigabyte young gen, which is kind of absurd, but it's what we need to have to ensure that all the temporary objects do not get promoted into old gen and lead to GC problems or full GC. So what people need to do is realize that although when you're coding something that object creation is cheap, cleaning it up is not. So be mindful of how many objects you create and whether or not you can reuse existing objects. One example that comes to mind, I believe, is the storage types for the storage policies where you say, I want hot, so I want so many, or what is it, warm, so I want so many hot disks, I want so many archive disks. It'll actually sit here and loop multiple times, building an array every time telling you what sort of types you should choose in what order. It's the same every time you call it, saying that I want 3 replicas or I want 10 replicas. So why isn't that cached? That generates a tremendous amount of garbage. And it's by no means not the only thing in Hadoop that does that, but it's just one that comes to mind. So that's I think the final thing that we need to focus on. When I rehearsed this, I went on for about 20 minutes. So we have plenty of time for questions now. I dropped it because I didn't want to answer your questions, Sanjay.
Right, so after that amazing mic drop, anybody got anything for? Oh, there you go.
So one quick question on your ops per second. So that was with no writes happening. That was 400.
No, that it was dumb. Whoa, you guys wanted louder earlier. Okay, is that better? That was dominated by reads. What the heck? Oh, we normally run at about 20 to 40,000 ops per second. I think last I checked, about a third of those. Am I standing too close to something? About a third of those were write ops. And in the case where we achieved rates that high, I believe it was a job that was flooding, globbing from all of the tasks. So it was a bunch of list status, it was a bunch of file status. So many of those hundreds of thousands were read ops. Write ops is something that we need to look at improving. For years, I've been wanting to get back to the fine-grained locking support, so that you're only locking certain areas of the name system tree. But as anybody who's known me for the past few years, I've lamented that snapshots derailed that.
Right. So what numbers are you seeing? And I assume you guys have put in the what numbers are you seeing? And I assume you guys have why is happening, you don't hold the thread.
We don't what?
Thread, you not lock on the thread. You actually queue the write and the RPC thread goes back. Right?
Yes.
Yes. Yeah, could you repeat the question real quick?
A lot of it, we haven't specifically measured, or I haven't looked. I know that I believe I've seen in excess of 10,000 write-ops. I mean, it's highly dependent on how fast you can sync to disk. Hold it.
You're okay. You're okay.
Oh, okay. Is it working?
No, it's not working right now.
Hello, hello. Yes. Okay, I think I have seen in excess of 10,000 write-ups per second. The thing that used to make, and as I guess I was mentioning, that's also largely dependent on your sync times. I think unlike most of the community, we're not using QJM, we're using NFS as one of our edit directories, and that has sub-millisecond sync times. But as you alluded to, there was a change I put in a while back that log sync happens asynchronously. It used to be that the write handlers or write operations would get the lock, they'd log the edit, they'd unlock, then they'd sync, and they could wind up tying up all of the handlers. If anybody did JStack, you probably used to see a bunch of your RPC threads all blocked and renames, creates, etc. I changed it so that the RPC layer response could be deferred, so log sync became a no-op, and the handlers were immediately available to process other operations. And this had a tremendous impact if, for instance, you had a lot of read ops coming in while you were waiting to sync out your edit ops.
One more question. Hey, Chase.
What's your hardware spec, like the cores and clock speed, cache, or disk memory?
Guy next to you would be better giving hardware specs than me. It's good stuff.
Yeah, basically you look for single thread hyper-threaded performance, single thread turbo performance. So you have fewer number of cores. So in the newer clocks, you have higher turbo clock rate. So with the newer processors, you have various choices in a lot of cores versus turbo speeds. Right? We try to pick one with the higher turbo speed with fewer hyperthreads, basically. So that gives us, because most of the time is spent in that lock, how quickly you can exit the lock. So it depends on the frequency. The second is we don't use QGM, so we use NFS. So there are two edits directory, one on the local disk, one on NFS. For both, at least on the local disk, we make sure we turn on the cache. Even a SATA drive with the rate controller cache turned on would be really helpful than just a plain SATA drive. Even more than just an SSD. On drive, battery backed cache helps. So these are the two main things.
Yeah, as Rajiv mentioned, you want to have, well, mostly mentioned, you want to be sure that you're writing your audit logs and your other logs to RAID, SSD, anything but a spinning disk. The latency involved, 6 to 8 milliseconds, will severely impede your performance because the edit logs consume a good amount of time and limit the number of ops you can have. And I guess that's important. We disabled logging file status operations. They are just so ubiquitous across all tasks. We really don't care if somebody just statted something or not. And I can remember there's a config option for the audit logger of which operations you don't care about. I would encourage you to disable that, and you will probably see a boost in your throughput as well. It's been so long since we did it. I do not remember the comp off the top. Yes, if you search for the HDFS audit logger class, I believe it references a config or somewhere in that vicinity. We can look it up later today if you can't find it.
Okay. Thanks, Daryn.